Now, it's not just an obligation as far as the community is concerned. The funding agencies also have to look at ourselves in terms of how we're managing the science as we go ahead from here in ways that are going to be optimal as far as the community is concerned. So let's talk a little bit about that. Now, part of the problem in doing all this is the people that are in the room. As Schmidt said, incumbents rarely invent the future. How do we sort of deal with that? How do you deal with what Clayton Christensen has called at the top of the slide, the innovator's dilemma? How do you try to be excellent? Improve. You know, you're already excellent. How do you try to be even better in the midst of excellence? That's the fundamental dilemma going ahead from here. So the foundation, we're trying to think about how do we do this, and we've got some things in the works. So clearly stimulating interdisciplinary activities is part of it. Working at the edge. We're sort of playing with a program now, actually, that goes to something like fellowships at the edges. That's something to just sort of watch for. So here are some of the things that we're thinking about, and I'll tell you about in a second. An integrated global systems science program, a couple natural human systems, ecology of infectious diseases, and this basic research to enable agricultural development. Now, I won't open that up too much, but let me say something about it. It doesn't have directly to do with ecology, but this is a partnership between the National Science Foundation, Bio Directorate, and the Bill and Melinda Gates Foundation. And what it's designed to do is to take basic genetics and translate it into the field of developing nation agriculture. What this program allows us to do, though, is we're putting in $24 million over the next 5 years, and the Gates Foundation is matching that. But the nice thing about it is we'll be able to take our funds and fund U.S. investigators and laboratories like we usually do, but we'll be able to partner that with Gates money and go directly into developing nations and support labs and PIs in those countries using the private sector money. We're going to look for additional partnerships like this, where we get the federal government together with the private sector to do this kind of program. Well, let's take a look at some of the others that we're doing. So we have these multidisciplinary programs in place. We have the dynamics of coupled natural and human systems, which is between bio, the geosciences, and social, behavioral, and economic sciences, along with the Forest Service. So shortly after I arrived at NSF, myself and Margaret Langen, who's sitting in the back, along with David Lightfoot, signed the first Memorandum of Understanding at NSF, hooking together 3 directorates across this coupled natural human systems program. We use stimulus money to double the amount of money in that program, and we're going to keep it double as we go ahead from here. So coupled natural human systems is going to stay a priority. The ecology of infectious diseases, we increased that program by 50% with stimulus money, and we're going to keep that one going as well. We have this whole area of interdisciplinary training across biology, education, and math and physical sciences. We're doing a lot of partnerships with math and physical sciences, a lot of which are not directly relevant to the ecological community. They're in areas like synthetic biology, they're in biophysics, they're in chemical biology and biochemistry. Whole new bridges have been built out to the math and physical sciences from biology over the past couple of years. Here's one example that has to do with chemical biology, where we have a jointly hired program officer between the Bio Directorate and the Math and Physical Sciences Directorate in order to facilitate the large number of proposals we were seeing at that interface. If you look at the funding profile for the chemistry division within Math and Physical Sciences, 40% of their funding now goes to the biological sciences as a result of the interest in chemistry in biology. In the next image, we've ramped that up. So in partnership with Tim Colleen in the Geosciences Directorate, what we've done is we're taking 17 program officers, half from biology, half from geosciences, along with 3 support staff. We're putting them together on the 6th floor once we get some details worked out with the union. And they will form this integrated global systems science group. And they will have a bunch of funding in order to bring up these kinds of programs. They're going to have a distinguished speaker series. They're going to do cross-directorate activities. And it really is going to stimulate this conversation that has to do with this whole area of multi-scale analysis. Multi-scale analysis that hooks together the geosciences and the biosciences in new and interesting ways as we go ahead from here. But as Bertrand Russell said, and taking a tip from him, every so often you want to just take a look at the kinds of things that you do on a regular basis and see, can I even do them a little bit differently than I have up to now? And at the heart of NSF, of course, is the peer review process, which we're going to hold on to. We're going to hold on to going forward, and we're going to think about some ways in which we can do that even more creatively. So in the next slide, some of the things that we're thinking about in biology as well as other places in NSF as well, is to explore these new ways for the process of discovery. New ways using things like crowdsourcing. So those of you who looked at the New York Times yesterday and the final report out on Netflix, where they awarded the $1 million to the group that finally cracked the code, well, they came up with the improved code. That was a crowdsourcing phenomenon. Now, what fascinated me about the whole Netflix issue and the Napoleon Dynamite problem within the Netflix issue was the fact that Netflix posted this problem, and they had 41,000 teams write into that problem. The National Science Foundation gets 40,000 proposals a year. They have 41,000 individuals thinking about how to improve an algorithm for picking movies. It's just a fascinating, interesting case of social networking. Crowdsourcing, the notion of clean slate going all the way back to ground level and thinking from first principles exactly what's going on in some of these systems and how can we do the science even better than we have. We're going to require creativity training for permanent program officers, at least in the Biodirectorate. We're looking at synthesis centers. The National Center for Ecological Analysis and Synthesis is up for re-examination, and there's a team already looking at that in terms of what the next steps will be as far as NCs is concerned. We're looking at using prediction markets in order to identify some PIs who are interested in using prediction markets to find the very, very best places in order to be doing science. And we've already piloted this sandpit process. Just to give you a sense of how that works, we're partnering with we partnered with the United Kingdom in an area called synthetic biology. That was the problem set that was posted. And we asked for applicants, and they were only allowed to write one page on synthetic biology, their best idea. And the other side of the page, they had to answer a series of questions prepared by an industrial psychologist that went to questions related to collaboration and so on. Those 170 proposals then were evaluated by an external advisory committee of 5 people that was international. And they identified 30 of those ideas that they thought were really, really good. Those 30 individuals from both the UK as well as the US were flown to Washington and put in a very nice place outside the city, along with a review team, along with program officers, and they had a week to begin to write their proposals in synthetic biology. So they wrote them on the fly, along with people in the room who were theoreticians, who were empiricists, who were ethicists, so that if they had an idea, they could say, you need this ethicist over here. And by the end of the week, they had 5 to 6 really great ideas fleshed out, with the program officers already evaluating them as they were going ahead. And those 5 or 6 teams then were told, prepare a proposal within a month, as long as it's consistent with what you've already told us, it will be funded. So they've been funded now. And this is sort of a new way of thinking about how you find the very best ideas as you go forward in any particular area of science. Now, to some extent, that's sort of what's been going on with NEON, and it goes on with the MREFCs in general. You have this iterative process where you find the very best science, and you're depending upon the community. You're coming together in real-time reviews. So these folks, the NEON folks, know who their reviewers are when they go into these meetings. They're all just sort of arrayed there on the panel. And it's this back and forth that creates the really exceptional science as you go ahead from here. So managing the life sciences, managing the science in general is something that's very much in front of us right now. And we're trying to think as creatively as possible about what these institutions should look like in order to marry together with the institutions, the universities, the research institutes in the country, as we go ahead from here into the 21st century.